another video that explains about 10th grade advanced algebra materials. Now we are discussing radical equations, part of the chapter 8, Irrational Algebraic Function. So what is a radical equation? That is the first thing that we need to discuss. A radical equation is an equation in which a variable appears under a radical sign. It means it's not just a radical of a number, so we need to have the variables as your radicand. Now we have radical equations. So if your equation doesn't have any variable as the radicand, instead just numbers, we still don't have radical equations. So these are the examples. So we have this x as the radicand, this is a radicand, and this one is radicand. So the next thing is the objectives. So if you have these problems of radical equations, you need to find all values of x that satisfy the equations as usual. Whenever we have equation problems, no matter it is radical or rational or quadratic, we need to find all possible values. So your final answer must be in the solution set. Don't forget, this is the last statement. And you need to be careful with the extraneous solution. Why? Because later you will find out that we still do the irreversible steps, which is it's a bold move in algebra. So let me just show you the steps. It looks like a long thing, but it's actually not. So it begins with isolating a radical. So if you have a radical on your equation, you need to isolate it. If you have more than one radical, you need to isolate at least one on the left member and one on the right member. And if you have three radicals, well, you need to at least separate one radical, and then after that separate one again, and then separate. So let's just I will explain later on the examples. And after you isolating the radical, you get rid of the radicals by square or cube, or it depends on the polynomial, on the degree of your or the root index. Sorry. So after you square it to get rid of radicals, you need to evaluate on your equations, is there any radical left? If there is still a radical, it means you isolate that radical again, and then after that you square it or cube it and so on, and then check again. If you have no radicals, you isolate it again, and so on. After you have no radicals on your equation, now we go to solving the polynomial equation. And then don't forget, after you find all the possible values of x, remember to check the solutions and discard the extraneous ones. So remember, for the rational algebraic function, we put the domain first. The domain is the filter, so you can directly know which ones are the extraneous, which one is the real solutions. But for this one, we cannot use that. So the last thing that we can do is just find all the x and then checking one by one, put it into the original equations, and then find it if it satisfies or not. So, and then all of the solutions that satisfies, put it into the solution set, and then you can stop. So let me just show you the examples. I will show you 3 examples. I hope it's enough. While I'm showing you the examples, I still show you the steps here so we can relate. Okay, this is the first example. As you can see, we have an equation of a radical. This is the radicand. So let's start with isolate the radical. If I isolate the radicals, I make the radical alone on the left member or on the right member. So I will do that in these examples by subtract both sides by 5, right? So it becomes isolated. Now let's go to the second step, square or cube to get rid of radicals. For this one, I prefer, of course we can use the square both members. I square the left members, I square the right members, don't forget all of it. So what is the result of square root being squared? It's cancelled. So the left member, you have already gotten rid the radicals because it's being squared. The square root is cancelled. But on the right member, don't forget, the result is this. And then after we have already get rid all of the radicals, so are there still radicals? No. So we go to the solve the polynomial equation. Solve the polynomial equations because we have a quadratic here. Of course, the best move is to make one side into 0. So I just put all of the members on the right. So by this one I minus 22 and plus 12x. So 0 equals 4x squared minus 8x plus 3. So whenever we have quadratic equations, of course, we need to factor it, or if we cannot factor it, just the quadratic formula. But this one, it can be factored. So let me just factor this. It's 2x, so it's 12 and negative 8. It is, yeah, negative 1 and negative 3. So we have two possible values of x, which is the first one is a half, and then the second one is 3 over 2. So let's check now. Check the solutions and discard extraneous ones. So now let's check half to the original. Use the original one, okay? And then 3 over 2 also. Now this is the checking part. So if I put half into the original one, so it will be square root of 22 minus 12 times half is just 6, right? Plus 5 equals 2 times half is 1. So in the end we have square root 22 minus 6 is 16. So yeah, so it's 4 plus 5 equals 1. Now this doesn't make sense. This doesn't satisfy the equations. So half we have to exclude it because we have to discard it. It is an extraneous one. So now let's go to the 3 over 2. So it becomes 22 minus 12 times 3 over 2 is 18 plus 5. 2 times 3 over 2 is 3. Now it becomes square root of 4 plus 5 equals 3. Now square root of 5 is 2. 2 plus 5 is 7. So it doesn't satisfy also the equation. So these both solutions are the external solutions. So we don't have any real solution for this one. So that is our final statement. There is no solution. So we can write it this way or this way. Yeah, this is the first one. So we can relate to all of the steps. And I hope that you remember whenever we have the solutions, don't forget to check first, because we can have the external solutions since we are squaring both sides. When we squaring both sides, actually we multiply it with a variables, and when we multiply both members by variables, we might create external solution. So now let's go to the second example. So the second example, we have two radicals. Since we have two radicals, we need to isolate a radical. It means let's separate the radicals, one to the left, one to the right. So this one I will move it to the right. Yeah, of course I cannot just move it, but just, yeah, you get the idea. So we add both members by square root of x squared minus 4x minus 5. So yeah, so it's moved there. Now we have isolated radicals. Now let's square it. Square both members. Square left and square right. On the left member, since it is a square root being squared, so the square root is cancelled. It means we only have the radicands left. But for the right member, don't forget that it is a plus b square situation. So it will be a squared plus 2ab plus b squared, right? So this is the result. Don't forget. So now we still have a radical, right? When we go to step, are there still radicals? Yes, we still have it. So let's go back to isolating a radical. But how we isolate these radicals? So let's just move the other terms into the left by adding or subtracting both sides with that term. So this is so I do minus 1 minus x squared plus 4x plus 5 equals 2 times square root of x squared minus 4x minus 5. Now let us simplify first the left member since it's quite complicated, but actually not. So it's cancelled. X squared minus x squared is 0. Okay, 4x minus 4x is 0. So the one that being left is negative 13 plus 5, which is negative 8. Negative 8 equals 2 times square root of x squared minus 4x minus 5. Now we still need to isolate these radicals. So let's isolate these radicals by divide both members by 2. So it will be negative 4 equals this one. We have isolated the radicals. Now let's square both sides. We go to the second step, square both members. So but of course you can get the idea that actually it's impossible since a square root of something cannot be negative, right? So actually we have already known that there is no solution for this, but just let's pretend we don't know. Let's just respect the steps. Let's square both sides. Okay, let's square both sides, and then we have 16 equals, this one is cancelled, x squared minus 4x minus 5, and then because this is quadratic, make one side into 0 or one member to 0, so we have minus 21. Since it can be still factored, so yeah, let's factor it. X minus 7 times x plus 3. So we have two possible values of x, although yeah, just keep in mind that we pretend we don't know that these are not the solutions. So 7 and negative 3. Now let's check that into the original equation. Don't forget. And I leave it to you, but by checking it, you will find out that 7 will not satisfy the equation, and when you put negative 3 to the original equations, it's still not satisfy. It doesn't satisfy the equation. So yeah, the solution set is none. We have no solutions. So keep in mind again why I say that you just need to respect to the steps, since yeah, of course, for those of you who are very good in concepts, you can stop at the middle when you find out that a square root of something cannot be equal to negative. You can find out that actually you don't have any solutions. But if you're not good at the concept, I mean, you just you can still follow the steps. You can still follow the steps, and you can really be assured that in the end you will find the same answers. So yeah, just follow it and then checking it. Don't forget, okay, since 7 and negative 3 in this case is not the solutions. So let us go to the next example. The last one. So now, the last one, we combine two rational and radicals. So chapter 7 and chapter 8 collides. Okay, so we have fractions and radicals. So we need to recall back, how do you solve fractions or rational algebraic functions, or sorry, rational algebraic equations, and how do you solve radicals? Okay, so now let me just show you to remind you how to do it. First, let's deal with the fraction first. So originally we always stated the domain first, right? But let's just, because in the end we need to check all the solutions, let's just leave that. Okay, let's just try to solve first. And now this one I want to show you that actually we can tweak this one, so we can have a simple one. I changed the order of the denominator, and let me show you that this one can be factored. Actually, it becomes square root of x plus 2, square root of x minus 2, right? Yeah, I hope that you remember that. So let's put that. Why do I do this? Because in rational algebraic equation, we can get rid of the fractions by multiply all by the factors on the denominator, right? So this one, since we only have two variants of factors, we can multiply all by these two factors, which is square root of square root x minus 2 and times square root x plus 2. So when we multiply all by these two factors, the result is 2 times square root of x minus 2 plus square root of x times square root of x plus 2 equals x plus 4. Now we have gotten rid of the fraction. So let's just simplify these polynomials first. It become not polynomials. We simplify these expressions. So let's just 2 square root of x minus 4 distribute plus x plus 2 square root of x equals x plus 4. We can still simplify this. Let's collect the like terms. We have like terms, this one and this one. So it becomes 4 square root of x. And let's just let's just, everything put into the right member. So it's x plus 4 minus x. So it will be, when I simplify it, x minus x is 0. So plus 4, it's 8. So let's isolate the radical, sorry. So by dividing both by 4. So I have this and I square it. So this is the possible solution for you. So don't forget, we check it. Check the solutions and discard the extraneous one. Let's just put into the original equation. Okay, checking. So when I put 4 into the x, it becomes square root of 4, which is 2, minus square root of 4 is 2, over 2 minus square root of 4 is 2, equals x plus 4, is 4 plus 4, and 4 minus 4. So we have zeros on the denominator. So this one cannot be your solution. And we have another situation that we have no solution. So please keep in mind, so because I randomly choose the examples here, well, accidentally all the examples shows no solution at all, but actually it's not like that. We might have solutions. So let's just do your practice by doing the homeworks and just do all of these steps. And don't forget, when we combine the fractions and the radicals, we do the fractions first. Okay, just like this example 3, and then after that we go to solving the radicals by referring to these steps on the the diagram, the flow diagram on the left. Okay, this one. So yeah, that's all for now. I hope that you can assess yourself whether you have already understood this material by doing the practice, and you can ask later in class if you have still questions. Good luck, happy practicing, happy learning. God bless you.